AI is progressing at breathtaking pace. In the past couple of years, we have seen chatbots become more and more capable. We are moving towards agentic systems that are adept at doing many different tasks. Given the progress with generative AI, it is not hard to imagine having intelligent AI assistants associated with EDA tools. I would like to see something like GitHub Copilot for EDA tools, which can generate code or scripts for you, explain specific snippets, help you debug errors and warnings, answer questions, and guide you on how to achieve a certain task. Going further, with the advent of protocols such as MCP, which enable LLMs to interact directly with tools and other agents, I can imagine having a completely automated LLM-driven DFT or even EDA flow. The user just gives high-level instructions and the LLM uses all the knowledge from previous runs as well as information about a user's environment to run a complete flow. It asks the user for information that it needs or clarifying questions and pursues multiple paths to achieve the best possible result for the user. This will lead to a tremendous increase in user productivity and will decrease the amount of information and experience a user needs to effectively use EDA tools. Generative AI has uses beyond user productivity as well. For example, it can help guide users towards writing RTL that is easier to test or diagnose. We know generative AI has the potential to bring about massive improvements, and we at Siemens are certainly exploring a number of uses for AI within our tools. Certainly, while generative AI is extremely powerful, many of the core challenges within test have a higher chance of being addressed using traditional AI ML or algorithmic solutions. I am talking about things such as compression advisement or reusing information from previous ATPG runs to accelerate and guide subsequent runs. These are some of the areas we are actively exploring using ML. The classic use of machine learning in test has been in yield learning, and at this point, every major fab or fabless company uses volume diagnosis based statistical learning for yield improvement to achieve substantial savings. As designs grow bigger and bigger, we are hitting various limits. We need to support additional newer defect models to ensure robustness for mission critical applications such as automotive, as well as to address issues such as silent data corruption. These lead to an increase in pattern count that won't even fit in a tester's memory. This necessitates the need for adaptive test and pattern selection. With such large designs, optimizing the test hardware such as multiple EDT blocks to achieve the best coverage and lowest pattern count is an important challenge. Traditional AI ML algorithms are more likely to help with these problems as compared to generative AI. Data confidentiality and data access is an important challenge. Many of our customers are sensitive about their data, and that is understandable. We have a few ways of getting around this problem. For generative AI applications, we designed them in a way that they can easily plug in to the customer's ecosystem and can work with their LLMs. In addition, we support fully on-prem installations via Fuse that uses open LLMs that can be installed and run locally at a customer site. With the continued improvement in the quality and results of such open models, this is certainly a viable path. This ensures none of our customers' data leaves their premises. For AI ML applications in general, we often develop a prototype and then partner with a customer to improve it further. Once the product is ready, it is designed to run at the customer site and learn from the customer's internal data. But none of this data or knowledge leaves the customer site. The data is simply used to improve our tool's performance for the customer.